All right. Hopefully, that's better, at least for now. All right. So some of you know me, some of you do not. We got a big freshman class this semester. So I'm Colin. I'm one of the seniors. And for some reason, for the second time, I'm your president, which is kind of surprising why you guys asked me to do it again. But that's besides the point. Shall we get started? Because the business is boring and the rest of the stuff is a little too interesting. All right, so it's just a general survey of our officers this year. Some people have changed, some people haven't. Additions this year are Kelly as the SGA rep, Matt is historian, Angela social media, then Cassie is switched to vice president. But for the most part, everything else is the same. Cassie?
There we go. So we still don't really know what's going on for Skywarn. Right now, it's still slated for September 23rd, which is one of our meeting nights. So this will replace our meeting for that night, supposedly, as long as there's not another hurricane that comes, because they already had to cancel on us. As some of you know who were signed up for the meeting on August 22nd for the basic class. I messaged the National Weather Service because you all boop me. So I messaged them and they're like, we don't really know. I'm like, well, we have people who need to do the advanced class, but they need to do the basic class first. So the National Weather Service meteorologist says she has to go talk to her boss, but she's saying as of right now, anyone who was on the 22nd class can still do the advanced class, but you're going to have to do the basic one in November when it's available again. But I'm still trying to get more information from them, but they're kind of panicking because even though the hurricane's not by them, they're still having a freak out over there, and it's a mess. So once I get more information, I'll send an email out, but we're still slated for September 23rd, 7 to 9 p.m. for the advanced Skywarn class, virtual. There will be a link to sign up. I haven't gotten that either because same excuses apply. Any questions?
So the short version of that is they left us on red.
Yeah, what he said. There's your Spark Notes. I love being left on red. If you know me, I hate being left on red. It's my pet peeve. Yeah, okay, we're going to keep going. There you go. Oh, wait, do I do this too? Yeah. Oh, so so since everything's going to be virtual this semester, we're trying to find new ways to be engaging since everything's on Zoom. So we're starting a monthly guest speaker thing like some other AMS student chapters do. So each month we're going to try to have a guest speaker from a different branch of meteorology come and talk about their job briefly, then open the floor for any questions anyone may have. We already found all the guest speakers. We don't know when they're coming and what months, but they're already all picked out. So we got people from National Weather Service, NASA. We have a grad student, and and a broadcast. We have a broadcast met. So it's going to be similar to the one we did over the summer with Aaron Christensen. But it's going to try to be shorter because that was like an hour or something. We're going to try to condense it into about 30 minutes, so like half the meeting's that and then half the meetings are business. So
hopefully I won't have a severe thunderstorm warning issued in the middle of it. That'd be great.
Yeah, that was funny last time. All of us would have one issued technically. We're in Melbourne. But so our next meeting is 2 weeks from today, and our guest speaker, I still don't know how to say her last name. I meant to practice it. She sent me the pronunciation of her last name, but you can read. She worked at NASA. So we're doing NASA for the first month. She was a meteorological systems analyst at NASA. She's currently a service manager for Baker Hughes, and she graduated in 2011 with a BS in meteorology and a minor in communications. She'll be our first guest speaker in 2 weeks from today at our next meeting. So anyone who's interested in NASA and stuff in the space industry, get your questions ready for this one. Okay. Yeah, I mean, she's not in here, so at least she didn't hear me not know how to pronounce her last name. But she'll be our first guest speaker in 2 weeks. I don't know what the date of that is, but there's calendars. That's what they're invented for. Okay, so this was partially Colin's idea, or most actually all of Colin's idea. He had an idea of doing different game nights. So over the summer, if you didn't know, we did lots of Cards Against Humanity nights, and were very interesting and very fun in ways, but very weird. So we're trying to think of other activities that are more child and friendly to other people. So we're trying to think.
Things went poorly is what she's trying to say. So now we're going to a clean game so we don't avoid any other problems.
And it's more of an official club game versus a side game. So Colin had the ideas of weather bingo, weather Pictionary, weather Jeopardy, and I forgot to capitalize the J, so now my OCD is kicking in. So I told Dr. L this during class, and he's like, please do Pictionary, please do Pictionary. Mike and I want to come. We play Pictionary with Mike's family every Saturday night. So if you didn't know, he likes to play Pictionary, apparently. So we're thinking of trying to do a game night of some point with Pictionary. At some point, anyone be interested in that? I'm trying to flick the camera so I can actually see people nodding or hand raising. Okay, I see lots of
Is there
nodding.
not a way they do a? Is there not a way they do a poll on Zoom?
Nope. As far as I know, no.
3, 2, 1, spam the chat.
Oh, that's actually an idea. I don't know how to use Zoom still, and quite honestly, I don't really know. Anna, are you getting these notes? Am I going too fast? Oh.
No, I'm getting it.
Okay, I don't know where you went because I only see 4 people at a time, but I want to make sure you're getting these notes because I know I'm going fast a little bit.
No, I'm good. I got it. I'll
Okay.
post the notes like 30 minutes after.
Perfect, thank you. I wanted to make sure we're on the same page. So we'll figure out a date for that. Maybe do as like a Friday night game or something on the weekend, since a lot of us are busy during the week with stuff. Just a fun activity, not mandatory, where we try to draw weather things and we all failed miserably because probably none of us are Picasso, except maybe like 2 people in here.
I think they know what Pictionary is.
I know they do. Yeah, we're gonna keep going now. And finally, or one of the finalies, some of you do not follow us on social media. We're trying our best to communicate as much as possible on email, but the emails are very hard to send because through Engage, you have to do like 5 steps to get the email link, and then you have to type the whole email and still send it. So we don't do emails daily, but on our social medias, thanks to, I don't know where Angelo is. He's somewhere down there. I can't see everyone. Thanks to
I'm
Angelo.
above you on like my screen. So you were pointing up and I'm actually above you.
It's different for everyone.
It's different for everyone. I don't know where you are, but Angelo has been doing a very great job pushing out our meetings, except I had to remind the meetings about tonight, but that's besides the point. He's been doing everything else perfectly fine. So we have the Facebook page, which is what you see to the left. We have the Facebook group where we post, where you get the social Saturdays, where we do the pictures, share weather posts, interact with alumni. David's somewhere down here also. He's an alumni. I don't know where he is in the camera, but he's down there somewhere, and he's an alumni and works for National Weather Service. So, like, there's ways to interact with alumni in that group. And then our Twitter is the one to the left, and our Instagram is the one to the right. Most of you follow us. We just wanted to put a general reminder out to just so everyone's on the same page of when meetings are and what's happening, if we don't send emails out too much harassing people. So that was just a general plug. Okay, now I need to stop this. I couldn't combine the PowerPoint, so I have to reshare.
Do you want me to share my screen, or are you going to do it?
You want to share? You can share your screen.
No, we got it.
Okay. Hold up. Let me get that. My computer's running really slow. Share screen. Share. There we go. Okay, Angelo, this is yours. I'm just going to flick through. So this is Angelo's first time running it. We'll see how this goes.
All right.
Oh,
So,
I love it.
thank you. So for those of you guys who don't know me, I'm Angelo. I'm going to be the social media rep. So every month we do, in the past we've done a cover photo contest. So the winner of the contest is going to be our header on Twitter. So for the first one, I just kind of combined a bunch of different cloud types. So we got 12 photos in total, which was a great outcome for the first meeting. I didn't expect that many, but I was so happy to get a lot of photos, and they're pretty good ones. So what you can do is we're going to go through all 12, and then you could put your whichever one you like best in the chat with the number, and I numbered them throughout the slide. So in the end, just put your vote in as a number, and then whichever one has the most, that'll be the winner. And I have a notebook ready to tally, so you can go ahead and start, Cassie.
Okay. All right. Is this working? Okay,
Yeah,
cool. So you got that. That's number uno.
it's uno.
Number dos. Number tres. That's definitely not how you say that, but. As Rudy would say, there's power lines. Or as Dr.
I
O
was
would
gonna
I
say.
was just thinking that.
I just had to make fun of Rudy. It's fine. He's not here, but we still have to make fun of him in spirit. And I'm glad that everybody else was thinking that. That makes me feel better now.
I was looking at all the photos and I was thinking about that. I was like, thinking about what's in the way.
I'm moving.
Oh
trying to
no, offense.
Yeah, there's trees in the way there.
Scandalous. Okay. Does anybody want to see another photo one more time? Oh, shoot.
10 minutes.
Yeah, I know. I just saw the 10 minutes. I don't know how it's going to work with the link. Just try to go back into the same link. If something, God forbid, happens, I'll send out an email really quick of a new one. Because I did a recurring event instead of my personal meeting room, so I have no idea what's going to happen. As a disclaimer, if it goes out, try to go back in the same one. If it doesn't work, I will send an email. As quick as humanly possible, then hopefully 3 minutes. I'm going to go backwards.
New hurricane hunter data is very, very concerning.
We'll get to that in a minute. I'm just going through the pictures one more time because I didn't want to hit the wrong button and show all the names. And okay. And I'm going to stop the share. There we go. Okay, so just as Angelo said, just start typing your votes into the chat, and we're going to continue on. Angelo can, oh wow, you guys are going fast. Angelo can tally it while we're still continuing. And we're going to go back to this PowerPoint. Yeah, Angelo, just continue to tally, and you can just let us know at some point.
Okay.
Like, we're just going to keep going just so we can get back to, our lives.
Go ahead.
Okay. I just want to start with this meme.
Close.
Here's the meme of the time. Okay. So this is the NHC's forecast discussion.
It's the key messages from the forecast discussion. It's not the full discussion.
Oh. Okay, well, Colin, this is your time now. Go have fun.
All right, this is how where I pretend like I know meteorology. So far, I've done pretty good. All right, so really, the most exciting part of this is the item one, the first word. Is probably the most exciting thing about this. This is not wording that NHC does very often. And the main point of this is more or less a call to action. So, yeah, I just want to show you that. So, storm surge is penetrating up to 40 miles inland. Obviously, it's not the full, so look at the max area as the latest measure is 15 to 20 feet. It's not the full 15 to 20 at 40 miles, but Lake Charles is a few dozen miles inland, and they're looking at 9 feet of water. So, yeah, I mean, we talk about a lot about how it's the water is the biggest hazard. And I mean, this kind of shows it. This area also, for landfall, I think has up to 15 inches of rainfall as well. But let's see, we have 6 minutes, so I think I can start going in to the actual data, at least a little bit.
Just to say something real quick, to give
Yeah,
people
go ahead.
an idea of what's going on, NWS Lake Charles has actually evacuated. So there's nobody in the office, and they initiated service backup because of this storm surge. Just to give people an idea of how concerned the National Weather Service is regarding Laura.
Yeah, so to also go on that, so Galveston is currently issuing warnings, and Tampa is taking up the routine forecasting, at least for now.
I thought it was Brownsville or
Tampa has, if you go look at the AFD for Lake Charles, it's Tampa issuing. They split it up.
oh, gotcha.
I have a question. How often do like National Weather Service offices actually evacuate? Like, is it? I'm like assuming it's pretty rare.
I'm gonna send that one to David.
Yeah. That's a directive to David.
West didn't evacuate when Sandy was coming through.
Oh wow.
And I think San Juan stayed up for as long as they could, right? For Maria.
One was up until power went out and their radar was leveled. The main concern with the reason why Lake Charles, from what I understand, evacuated is because of the storm surge. I think they're reporting, I saw one of the buoys recorded a 38 or a 40-foot some odd wave in the Gulf of Mexico. So the fact that Lake Charles is sitting less than 10 feet above sea level, just to give you an idea.
Okay, thank you.
And David, you're in the U.S. Portland? Is that right?
Yeah, I'm up in Portland. Oregon, not Maine.
Yeah. Fair. I just want we have what, 12 freshmen coming in this year, and a good chunk of them are here. So I just wanted to make sure everyone understood who you are.
Perfectly fine. Just wanted to jump in and at least throw that tidbit out because, like most of you, I was very shocked that Lake Charles actually evacuated. It's very rare. A lot of the times it's shelter in place. So yeah, evacuating is definitely a red flag, for lack of a better term.
All right. So originally I was going to do a little more IDV today, just got a lot of new people, and I kind of want them to start getting into that kind of frame of making their own images and whatnot. But quite frankly, we got such a dynamic situation, I'm probably just going to scrap that plan. As I normally do, I like to go big picture, and yeah, I'm getting there. But thank you. Yep. So I have.
Yes, you do.
Cool. I actually have privileges this time. So that's amazing.
I already put it up ahead of time for once in my life.
Like I said, I love to pretend like I know what I'm doing. All right. So with 3 minutes to go, I'm going to quickly try to discuss some of the big picture features we got here. Because sometimes, especially as students, we like to talk a lot about details, but then we kind of forget the trough over Texas. And it's still important, at least to some extent. So basically, for the freshman here is what you're looking at is called the water vapor imagery. So basically, we have a satellite called GO-16 that sits up there and basically stays at the same spot over the Earth at all times, opposed to other satellites that basically kind of slice the Earth with their scans. I don't want to get too much with that, but my main point here is that we're more or less looking at water vapor. And why we want to do that is because we can see things like here. We have this is a trough. So you can kind of think it's just a low pressure, but instead of the surface, it's up higher in the air. What this can do in general is it can provide basically the winds that can push a hurricane, and it can be where you hear, we say wind shear, so it can bring wind shear as well. So I just want to quickly point out that we have at least a synoptic scale feature out here over Texas. You may have seen them talking about wind shear right before landfall. This trough is mainly what was going to provide that. And it's probably also providing at least some of the steering flow into the coast. But seeing as this thing is still developing here now, we're still seeing lowering pressure as it ramps up to the coast. It probably doesn't matter. Sure, maybe this prevents it from getting to Cat 5, but we're talking a couple knots difference between a 4 and a 5. As David said, with that much surge, and that much rain, it doesn't matter. Sure, it's academic at this point, and we got less than a minute. Where were we? All right. Moving along with this idea of a general big picture thoughts here first. So this is still satellite for our new folks, just looking at it in a slightly different way. What we're looking at is typically called the visible band. So it more or less looks like okay, what is echoing?
I think it's you through Cassie's
Oops.
thanks y'all in the same room. Yeah.
All right, cool. All right, so basically this is what is called visible imagery. So it kind of looks like if you were to take a photograph. So it's more technically, it's the visible, it's the blue, right? Yeah, this specifically is blue, the blue wavelengths. But this one of the advantages we have here, at least particularly with this satellite, is it's of a higher resolution than the water vapor or some of the other. It's the highest resolution product. And so to go on with that eye comment, I'm going to zoom in and with our last little bit of daylight, because this particularly works in the day. We're going to get a nice look at this eye as it comes in here, kind of our last visible imagery as we go into the nighttime hours. Yeah. If there's any shear from that trough, I don't think it's particularly affecting it overly much. That's David, were you trying to add comments? Because I didn't make through.
I didn't hear your question if you were asking me something.
Oh, it kind of looked like you were trying to add something to it. It said if you were, we can't hear you.
Oh, no. I muted. I was making comments to myself about how it's beautiful and how the trough is definitely not shearing it apart and whether an eye wall replacement cycle is going to happen. So that's it. Just making comments to myself.
I have a question.
Yeah, what's up?
If I don't want to interrupt you though.
You're fine.
So I know you definitely have looked at it more than I have been, and like you get all the updates and everything, but like where is the eye going directly towards Lake Charles? And then is it just going up the state like that?
Is the question, is that what the forecast is or what it's actually doing?
Yeah, like is it forecasted to go like right at Lake Charles and then like kind of just go north and up the state?
Yeah, I think that's roughly the forecast. We'll actually pull up what the NHC says here in a sec. Okay. Although they're probably gonna give us an intermediate update by 8, so we'll look at that a bit.
I've seen the European model seeing it coming out of Virginia again and strengthening over the Atlantic.
I did see that.
Yeah, so all right. So I saw that seems to be something talked a lot on social media a lot. So basically with these storms, what typically happens is, so it's so this is a tropical storm, right? And you can think of it as it gets most of its energy from the tropics, from basically the transformation of gas to a liquid is basically where it gets its energy from latent heat. After it makes landfall, obviously it doesn't have this moisture source of an ocean. And basically the storm transforms to what's called extratropical. And basically it's getting its energy from a different source, so it has a different structure. So that's what typically happens with landfalling hurricanes. Occasionally, those extratropical systems in general can, if conditions are right, if you have the right ingredients, create a tropical storm. So whereas I guess it's possible that some remnant energy from the storm could become extratropical, cross over the country, and then on a frontal boundary on that, another storm, I guess, could develop. But it seems kind of far-fetched, especially we're at 5-6 days from that. That's kind of far-fetched. I don't really I don't know some of the nuances on the physics in the Euro. But I mean, I wouldn't, beyond the fact that if there's some sort of energy with the warm waters in August that something could fire. Other than that, I wouldn't forecast that per se. Does that make sense? I'm trying not to go too speculative or complicated.
So one thing I at least want to mention to those that are looking at models, which is a fine thing, something that you will want to take into account is perturbations in the model. Take a look at the family and see how it's looking and see how it's performing. Going off of the operational model is one thing, but something that you need to consider is the family itself within the models, which has anywhere from 10 to over a dozen different runs. So take a look and see what the model in its entirety is, and go from there. And as Colin was saying, don't trust much of anything beyond 5 or 6 days out. It's going to change.
Any more questions?
I do actually have one. The family? Sorry, I'm a freshman.
Okay, so so you have the Euro, for example, as well as other models. What they do is that they run multiple instances of an event. So what you will see is that different variables will produce different outcomes within that model. Let me see, how can I explain this? Or try and, the point is that within a given model, there are going to be multiple outcomes depending on the input. So you have to take into account that some models might be saying that this will turn into another, Category 4 hurricane once it exits and hits the Atlantic off of the coast of Virginia. There are other models that might say that this is just going to turn into a nice little thunderstorm system for Virginia. So you have to take a look and see what all of those members of the model family are putting out and kind of adjust your ideas to that. Now, as a freshman, I'm going to tell you right now, models are very, very accurate, but you as a forecaster, as a scientist, are going to learn how models behave in certain situations. And as always, and this is why I tell people that call into the office, anything out past day 4, day 5, I can give you a general idea of what's going to happen, but there's a very, very good chance that it's going to change. So hopefully that answers it just a little bit, makes it a little less fuzzy.
So it's essentially variability. Like long term.
Precisely.
Okay.
And the further out you get from your starting point, the higher those variabilities wind up playing in on the outcome.
Got it.
Sorry, lost Zoom there. All right, so, and then if you're, oh, that's not what we want to do. So, and just so the freshmen know, this is, he's talking about all these various aspects of the model, is hopefully when you're a senior, like I am, you will could either take numerical weather prediction, like I'm doing from Dr. Ray. They don't offer it every fall. He kind of switches between that and tropical meteorology. But it's something to look forward to your senior year. Anyway, so where are we? All right, any more questions before I move on? All right, so as I was saying, we have a really good picture of the eye here. And you can see the new convection that's basically creating a ring around it. Going off of the idea of the eye wall replacement. So this is something you would see on this. Oh, you could see it on the IR as well. But basically, what we're talking about is a real basic way of thinking about it is that basically the eye gets reformed every so often, particularly in these stronger storms. Basically, you'll see the storm contract, weaken a little bit, the new eye form, and then the wind field, your strongest wind field will tend to spread out and it becomes stronger again. So now it's strong again, and there's a greater area that's strong. But this takes time, a lot of time, especially this close to the coast. So I wanted to real quick touch on that, just because we have a lot of people that don't know what that might be. So this is more or less the visible, and I have some from a little bit earlier today that might be kind of helpful since we're losing daylight. All right, so this is called Integrated Data Viewer for those that are new. We use this in usually when Dr. L teaches weather briefing, or pretty much almost every other class that he teaches, IDV will be somehow involved. So you're just looking at the same thing you did last time. The kind of cool thing about IDV is that you can make your own maps. It's a great learning tool, despite what some people say. It's great for learning. It's definitely not good for operational forecasting. I agree with that. But when you're learning about data, it's really helpful. It'll teach you about NetCDF files. It'll teach you about data visualization. It'll teach you about color tables. It's great for school. And you can go out of control and zoom out to the whole world. It's great. So I'll just at least put that in motion here. At least attempt to. I have a lot of data in here, so it's a little off time sync. So you kind of see from a little while ago, from this afternoon, how it looked. A little bit better daylight for the visible. I'm gonna switch, at least attempt to switch to the IR. That's not the IR.
You really
That's
are a mini
IR.
Dr. L.
Yeah.
Full form.
You try to do oceanography lab and get ready for this meeting.
Oh, no, thank you. You can have that all to yourself.
Potential density, go, drive it. Anyways, so this is, once again, more satellite, a lot of different ways of looking at the atmosphere, basically. We're basically looking at the reflected energy coming off of the clouds, basically, and you're more or less deriving a temperature from that, because, right, so anything that has a temperature, basically it radiates at some wavelength, and you can calculate that, so we can get derived top temperature. So we're not seeing through the whole star, we're just seeing the top. So basic rundown here is the white and black is very cold, and then progressively gets warmer here. So that's kind of useful. Later on, you'll learn about different cloud types and whatnot. The useful thing here is that, one useful thing is that this is good for day and night. So we can tell strong convection by the color, how cold the tops are. And, well, like I said, we can use this at night, so that's useful. That's just sort of the quick rundown of satellite. Satellite meteorology is used a lot in tropical meteorology, mainly because we don't have observations everywhere. So it's because we have global coverage essentially, or at least a very large coverage, particularly the ocean. There's a lot. The freshmen, you guys will have to take a class in remote sensing, which is generally considered both radar and satellite. So you have a whole class on that you have to take. So I know it's a long time from freshman year to senior year, but just hang in there. You'll pick up things along the way. So you don't have to completely wait till then. You have to wait till then to see the equations, but it's okay. You don't want to see them anyways. So, all right. I think we should probably get to the stuff that we'll really want to know, and that's where is it going? So, I'm not going to show any models for two reasons. One, we're so close to landfall, just look at the dang thing. Second of all, I don't want to open a can of worms with modeling. So we're going to more or less focus on observations tonight. Let's see. Anyone want to go look at Hurricane Hunter data? See what other can of worm I can open up? All right. People want to see me fumble through this, so let's go. All right. There's several different websites with several different ways of presenting data, but here's a really nice way of doing it from Tropical Atlantic. So what you're currently looking here is a NOAA aircraft. So there's two Hurricane Hunters. There's the Air Force folks out of Biloxi, or when they bug out of Biloxi, currently in Charleston. And then you have the NOAA Hurricane Hunters out of Lakeland, Florida. So as you can see, they took off at Lakeland, they flew out, and they're connecting data now. So kind of the three things that they have is they have a device that can derive the wind speeds off the waves. They have the ability to record the wind at the flight level that they're at. And they have the ability to do drop sounds. Freshmen, have you guys gone over weather balloons or radiosondes at all and anything yet?
No.
I would imagine not.
I have from past experiences.
Okay.
I know
so,
of them.
Okay, so general principle is, right, you have a balloon, you put a sensor on it, it collects temperature, moisture, and pressure data as it goes up, right? Roughly what it does. That's the rough idea. And winds. So the aircraft have drop sounds. So what do you guys think that does?
Isn't it dropped from the plane and it measures the pressure?
Yeah, it's just the same thing as a radio sound. It's just launched from an airplane and goes down instead of up. So obviously you're limited to the altitude of the plane, right? Which is fine. So that's what they do. They do the drop sounds. The NOAA also has a radar, a weather radar, a larger, more powerful weather radar on board. But the main point here is that they go in and they fly in. So here they fly in and they determine, we don't need to open that can of worms. They find the central pressure. They find the pressure of the storm. One caveat here to be a little careful is that on board the aircraft, they quality control it, but also NHC gets a final say as well. So they have this data coming in, and that pressure isn't necessarily the pressure that will be put into the advisory. NHC will make sure the answer makes physical sense to them. So they get a vote whether or not they agree with the observation. But for a moment, let's just take it at face value. Let's assume this is a good observation and they're happy with it. Assuming that is true, it is at 942 millibars. It's insane, quite frankly. I think we're almost to 10 millibars since this afternoon, to be honest.
We've dropped 10 millibars since this afternoon.
Yeah.
Wow, that's wow.
So I mean, I think the last full advisory at 5 o'clock, they had it at like I mean, it gained like 55 knots in the last 24 hours. I forget what the actual pressure drop from that was in 24. So the main bottom line is, we know from previous missions into the storm that it is strengthening still, at least from the pressure perspective. So you're probably wondering what all these colors are. This is the winds. I think the actual plot here is flight level winds. So basically, the structure of the hurricane winds is essentially at the surface, there's like a peak just off the ground, and then it decreases a little bit up. So that's why you can't just use the flight level winds. The extrapolating the winds down in the observations are actually pretty complex, especially with these stronger storms. My understanding is that some of the instrumentation, when they're this strong, there's a bit of a bias to be a little faster than what it actually is. I don't know a whole lot about that. You probably have to get a hurricane center person to actually be able to fully explain all the nuances of that observation. But that's basically what we get from the hurricane hunter planes. So any questions about this? So either this is really boring or I did a really good job. Probably boring. All right. Let's see how much trouble I can get with radar scope. Probably a lot.
I wonder how often the National Weather Service disagrees with hurricane hunters.
Well, it's not that they disagree. So their goal is they're to collect data. That's their job. So they're basically there to say, it's windy, it's windy, it's windy, it's windy, it's really windy. And it's the hurricane center. I mean, it's like any other data set, right? I mean, think about, have you guys ever looked at a surface observation and go, nah, that's not right? I mean, an extreme example is last summer, the ASOS at the Cape says that the dew point was -24 Celsius. Well, that's not right. Right? I mean, clearly the ASOS just says, this is what I think it is. Clearly there's a problem, right, with that. But it's not so much that they disagree, it's that whenever you take a measurement, there's error. And this hardware is developed for the most likely scenario. So when you start getting extremes, the hardware just has a limitation to what it can do. And it's up to the forecast. I mean, like I said, there is some data quality control done on the airplane, but it's up to the meteorologist to make the determination. And it's like any other data source. It's not so much, like I said, it's not so much disagreeing. It's just they provide the data, and you got to make a forecast decision. And it turns out this is all very complicated. And remember, their goal is to fly the airplane. Anyway, so I have a lot of things. Oh my gosh. If anyone's wondering why I just said, oh my gosh, the fact that SPC has put in enhanced risk for a hurricane, I wouldn't say it's never happened. It certainly does. But that's a little unusual. So basically, what they're saying is that it's generally primarily for tornadoes, especially for our tropical system. So basically, they're saying that not only is there a decent amount of tornadoes probably going to be spawned at landfall, they have pretty good confidence that it's going to happen too. I mean, it makes sense that it's a stronger storm that they did it. I'm just a little surprised they did it now. Anyways, so radar. That's what we were doing. I know I just threw a whole bunch of terms, so don't worry. We'll talk about those terms later at or later meetings. So, yeah. So this is our storm here. You know what? Actually, let's go to one pane. Let's not make this more confusing than it needs to be. Yeah. Thank you. I will fix that in a sec. Yep. It's because I didn't switch it. Thank you, Cassie. Okay, so now you guys understand why I don't want to be on TV, and I would be absolutely terrible at it. Hopefully now you guys can see the radar. Are you amused, Kelly? She's amused. All right, so here's what we got. This is our hurricane here. So basically you got this. So we're asking, is it gonna go straight for Lake Charles? Well, here's what do you think?
Yeah.
More or less going right for Lake Charles.
Yeah, because my best friend is in Baton Rouge right now, and she got out of work early, and I was like, wait a minute, I thought it was going through Lake Charles, but that's why I asked that.
Well, let's talk about that. So this is Baton Rouge.
Right.
Make this make this simple. We'll just go right to the eye wall. So let's call it 160 miles from the eye. Anyone want to venture a guess why Baton Rouge might be a problem?
It could be 160 miles wide, the storm.
It could.
Could turn. I don't know.
Well, let's test that first theory. So more or less, at least as the radar sees it, that's your radius of your storm.
Mm-hmm.
More or less, at least quick and dirty by the radar. Probably get a better estimate from satellite, but does that equal 160?
No.
Okay. Well, what's going on here? Is that part of the storm?
I think so. Yeah, I believe so. It's like the outer bands.
Okay. So
that could cause tornadoes and severe weather.
Okay. So what's the issue with Baton Rouge?
But yeah, no, I know that they're catching all the rain bands and everything, and that's where like the tornadoes and stuff can pop up. Potentially.
So what's the answer?
To what? What are you saying?
The question.
What's the question?
Yeah, like,
why is this a problem for Baton Rouge? We established it's not going to Baton Rouge.
Right. Well, no. So like they can still get they still are in. They're not out of the woods because like there's still a chance for like a tornado threat.
So you're saying that even though they're not near the eye, there's still impacts.
Right.
This is getting to a point. So one, this is called solving your own question. Two, so what I'm trying to get at here is that the impact from the storm are far outside of where the eye is going. That's the main point here to remember, is that there's still, because of the winds coming in this way, there's still going to be, now maybe not as much surge, but into the Louisiana coast, there will still be some surge, a few feet anyways, is what's currently forecasted. Granted, most of the surge is going to be in this area. That's definitely not the coast there, but you get the point. Mostly this area. But you still get impacts outside of it. Obviously, there'll be a lot of rain. Kentucky is looking at a few days from now. They're starting to be a little bit more confident of a potential flash flooding impact for Kentucky.
They're also, sorry.
You're good.
They're also thinking that there's going to be mild to moderate flooding for Tennessee Valley and into Mississippi.
Yeah,
according
so,
to NHC.
this roughly area there. But yeah, so obviously it won't be a hurricane at that point, but there's still a lot of moisture, so a lot of energy. So you still have the chance for some freshwater flooding there. Perhaps some rivers overflowing their banks because of the rainfall. And this is what we talked about. We talked about the rain, talked about the tornadoes, talked about the surge. I guess we haven't really talked about the wind, have we?
Yeah.
All right.
But I will say,
Go ahead.
I will say, I think Houston is gonna hopefully get lucky with this one. I don't think Houston's gonna get directly impacted. I think they're gonna dodge a bullet in this one.
Well, don't say that.
I'm not saying like they may not get anything. I don't know.
We'll
Do not
see if
tempt
there's
the
a
storm.
Lake Charles
Rule
Weather
number 1,
Service
do not tempt the
office
storm.
after this.
Do not tempt the storm. I don't care what the
Nope.
physics says. Do not tempt the storm. Yes, they at the moment it looks like they're getting out of this better than they potentially could have.
Yeah.
All right, so winds. We're talking winds. Well, let's go to NHC here and let's see what they have to say about winds. And 8 minutes. I can do this in 8 minutes. Who am I kidding? I'll go on a tangent in 8 minutes. Cool. All right. So, let's keep it simple. This is simple. All right, guys. This is from 8 o'clock our time. This is just out. Sweet. I managed to ramble long enough to actually get to a new advisory. It's all right. It's not a record. You guys know that. Well, they've learned already that I talk too much. All right. I'll attempt to be quick here. I probably won't be. So, I hope that you guys can now see the official product for the people that actually know what they're doing. Sweet. So, you got here maximum sustained winds of 150 miles per hour. They probably largely use hurricane hunter data to help them get to that. It looks like it hasn't really changed its speed. I don't know if it's changed direction much. I actually don't remember what they were calling it last time. But I know that speed's roughly the same. Let's see, anything here I want to talk about more? I don't know. Wind history is pretty good. So you can kind of see here the tropical and hurricane force wind, basically through all the advisories. So you can kind of see how at least the wind field developed throughout the storm. And let's see, let's go. Well, I did say we're going to talk about wind, so I will keep to that. So wind speed probability. So essentially, they break it up: hurricane, 50-knot, tropical storm. So anyone want to guess why they have a 50-knot? Any guesses why they might have a 50-knot product? All right, so there are users of Hurricane Center information that's an important number for them. I think the Air Force and the Navy might do something with 50 knots. Other partners might do stuff with 50 knots. So remember, as meteorologists, we're serving a whole bunch of different groups. And so they all have their different needs. And we try to do our best to accommodate everybody. That's pretty much our job, is to take the science data, repackage it into something that's useful for other people. That's pretty much our job. So, real quick here, so basically this is the basic probabilities. It's not really that interesting for such a large storm because it's like everywhere. But you can basically see it's at least a 90% chance of hurricane force winds for basically the whole state of Louisiana. It looks like they maybe might get it into Houston, at least hurricane force, maybe not the full brunt.
You're on tropical storm there, Colin, not hurricane.
Oh, sorry. Thank you. There we go. There it is.
That looks better.
Thank
That
you.
looks better.
I was about to say.
I was like,
Well,
whoa.
it would help if they didn't use the same colors,
Yeah, true.
but that's apparently what we're given. So, let's see, anything useful? Yeah, time of arrival. All right, let's go 3 days because that's kind of what's relevant. So, why do you guys think a product like this might be useful?
For like predictions.
Well, this is a forecast. This is a prediction.
Okay, well,
As it relates to meteorology or just the public?
Well, why would we create this? We got a lot to do during a hurricane, right? We got to
to
coordinate.
warn the
so-
general public.
Well, yeah, I mean, the general public has to prepare for it. So, like, this gives them a
Okay. So you're
Oh,
saying
it's-
that?
Oh, sorry.
No, go ahead.
Well, it's earliest reasonable arrival time. So isn't it just telling people like this is the earliest time when you can expect something like the hurricane to hit? So you should be prepared this time.
Okay. I mean, I like that answer. So another use is that emergency managers need to know when they need their equipment and personnel in place. So the cities need to make determinations when they're going to close things. Yeah, part of it is to help people know when they should have their preparedness done. They should be hunkered down or have evacuated. But a lot of it is also when do emergency management and whatnot, they need to get their equipment in place. I have a brother that's an EM, and this kind of information is when they decide when they're going to make sure their people are in position. I mean, obviously, they can't be moving stuff with tropical force winds. So they need to know when's the latest that they can position resources on the ground that are going to go ahead of the storm. Real quick, I got 2 minutes. We're gonna for some reason, we're gonna look at this chaos and war again. That's true. Well, real quick, we'll do that for questions. We'll come back one more time for questions, but I'm gonna try to get through this really quickly. So this is the storm surge graphic that potentially a Florida Tech grad may have had a part in doing it. I don't know if Phil's still at NHC in the storm surge unit, but if he is, he probably was a part of this. Anyways, so we got roughly our area here. That's our landfall area. So 15 to 20 feet here. I don't really know what to say about this, guys. I mean, this is kind of horrific. Even here, I was saying 4 to 7. Even over here, far outside, New Orleans is more or less okay with 1 to 3, at least, relatively speaking. But even Galveston 2 to 4, it looks like 6 to 9 to the more coastal. That's so pretty soon. That's a pretty good example of impacts far away from the eye.
So something I at least want to point out to actually everybody, especially even the freshmen. So for hurricanes to survive, like what Colin was saying, is that you need a source of energy, which is typically a very large body of water. So one thing you're going to have to realize is that if this storm surge happens and you get 15 to 20 feet of extra water pushing over land, this hurricane is not going to die out as soon as it makes landfall, because effectively it's got 20, 30 more feet of ocean water that it is pushing and pulling energy from.
That's a good